What we're going to take a look at next is an example of a confidence interval for the difference between two population means. So we looked at a confidence interval for the difference between two population proportions already in this chapter. Now we're going to look at the difference between two population means. So we're going to stick with the same example that we just did a hypothesis test for. You'll notice here I've given you the formula for the confidence interval, which is going to be the difference between the two sample means plus or minus some margin of error, where here is your margin of error. We are going to do this using the calculator. So we actually aren't going to use those formulas, but I did want you to be aware of what they were. So if we look down here at the example, very bottom of the view here, it says we're going to find a 95% confidence interval around the difference in population means from the previous example. And so our example was the students who had no sleep versus students who had sleep, and they were making attempts at free throws. So we're going to go ahead and go to the calculator to do this. And let's do this so that we can see the problem from before and then what we're doing now, which is our confidence interval. So like I said, we're going to go to the calculator, and we are going to stat tests. And if you scroll down, we are doing a 2-sample t interval. Okay, so that's option 0. We're going to hit enter. We don't have all the original data. We have the summary statistics. And if you notice here, it's keeping the data that we just input from the hypothesis test. So that's nice. It's all still in there. We do have to tell it our confidence level, which we're going to use a 95% confidence level. And again, we are not pooling those standard deviations. And we hit calculate. Okay. And so we had a sample mean from group 1 of 8, a sample standard deviation from group 1 of 2.3, and a sample size there of 25. We had a sample mean from group 2 of 12, a sample standard deviation from group 2 of 3.4, and a sample size from group 2 of 27. And what we ended up getting as our interval is from negative 5.61 to negative 2.39. Okay. The fact that that interval only includes negative values is important. That tells us that the number of free throw shots that group 1 made on average really does appear to be less than the number of free throw shots that group 2 made on average. If this interval spanned from negative numbers to positive, that would indicate that 0 was in that interval, and it might be the case that there was no difference. We just found in our hypothesis test from the previous example that it showed that at the 5% significance level, the group 1 mean was less than the group 2 mean, and we're seeing that consistently here as we find our confidence interval. So what we can say here is that we are 95% confident that the number of free throws, and I should be careful here, the mean number of free throws made by the group with no sleep is between 5.61 and 2.39 free throws below the mean for the group who did sleep. And that would be our interpretation.